Hi everyone, it's Mrs. Brimlow, and today I'd like to talk to you about converting rational numbers to decimals. So, in our previous lesson, we learned that all rational numbers can be written as fractions. They also have a decimal form as well. This is a skill you've worked on for multiple years, but I find it's something each year that students need a refresher on. So, that's what we're going to do today. If you have a copy of the notes, you should be taking notes along with the video. If not, you can watch the video and you can get a copy of the notes afterwards. Okay. So just to review a couple of terms we saw yesterday or in our previous lesson, terminating decimal. So a terminating decimal is a number whose decimal form has an end or terminates and does not go on forever, okay, to infinity. The last decimal place of a terminating decimal can always be named. Okay? So, all of the following are examples of terminating decimals. What is the last decimal place of each decimal? So, wherever the last number ends, that place value is what we consider the terminating. So, it ends in this one right here at the 5. There's nothing coming after it, and that is in the 10th place. Okay. The 3 in this next one is in the thousandths. Now, this one is interesting. Now, like I said, everything has a fraction in decimal form when we're talking about rational numbers. So, technically, this 8 comes before the decimal point since we don't have one there. That's what we assume. And then we'd put a 0 afterwards, which we don't usually write numbers this way if they don't have a decimal if there's no digit after the decimal. So technically, the 8 or the decimal ends right before it, and the 8 is in the ones place when we're talking about place value. Okay. And then 9 is in the hundredths. All right. So those are examples of terminating decimals, decimals that end at a certain place value. So repeating decimals. So a repeating decimal is a number whose decimal form repeats a predictable pattern forever into infinity. There are two ways that you can represent or show that a decimal is repeating. So here they give us 3, 3, 3, and then 3 dots, also known as ellipsis, to show that it's going on forever. And because we see a pattern, just the number 3 being repeated, we can assume it's a repeating decimal. Now, I don't love this form because a lot of people will confuse it with irrational decimals because those also use the 3 dots to show they go on forever. However, they don't have a pattern, which is why they're irrational. So I prefer the bar that you can see in this next example, where basically you shorten it to just a pattern and put a bar over it to show that pattern repeats forever. Okay. So we're going to use that, and that's once again what I would prefer to see here. So the pattern or what's repeating after the decimal in this one is 8. So -2 is unaffected. And so we write 8 with just a bar over it. Okay. Now, in this next one, I see it's 1, 2, 1, 2, 1, 2. So I have multiple digits repeating, which once again is okay. We just put a bar over all the digits that are repeating. Now, this next one, we have to be careful. We have -10 before, and that's unaffected. Now, we also have this 1 after the decimal, but the only number repeating is 8. So we just write the 1 and then put the bar only over the 8, since that's the only digit that's repeating. And then in this last one, we have 1, 2, 3 repeating. Excuse me. So this is how you would show a repeating decimal in using bar notation. Okay. Now, all of this comes back to what we call rational numbers. And a rational number is any number whose decimal form either terminates or repeats. It's also a number that can be written as a ratio or a fraction. So what I'd like you to do is pause this video, and I'd like you to go ahead and go through and circle or highlight all of the rational numbers below. So as a review from our previous lesson. When you're all set, you can come back and go through this with me. All right, let's go ahead and go through this. So I'm going to start with 4/9. That is literally written as a fraction. 5 and 2/9. as well as negative 1/2. Okay, so those are all examples of fractions or written as ratios, making them rational numbers. From our previous examples talking about decimals, we know they have to terminate or repeat. So right away I see 0.06 with a bar, so that's repeating. Same thing here. Okay. Also right above that, 3.444, that has a pattern that's repeating, so that would work. Now I don't see any more repeating decimals. Some people might think this is, once again, because of the three dots or ellipsis afterwards, but you have to be careful. There's no pattern in front of it. That's an irrational number. Has no pattern but goes on forever. Okay. The only other decimal I have is up here, and that would be an example of a terminating decimal since it ends at the 7 in the 10th place. Okay. All right, so some others that I can write as fractions and what we saw in our previous lesson would be negative 21, as well as negative 1,500. So we can write that as a fraction by putting each of those over 1. So when we have a positive or negative whole number, basically an integer, you can write those as fractions by putting them over 1. 0 is also um, a rational number. It falls into the whole numbers category, and it can be written as a fraction by putting it over 1. So we're left with pi, and we're left with this decimal that are irrational. Okay. All right, so now we get to our converting review. So basically, fractions are just division problems. Okay, that's all you're doing. This bar really means to divide. And if you actually think about it, it almost looks like a division symbol. You've got the bar and then two dots. That's what a division symbol looks like, what we've seen since we started dividing. So I thought that was interesting when I first saw that pattern. So when you read this fraction, it would be 3 divided by 8, because the fraction bar is a division symbol. Any fraction will be always be read as the numerator, which is your number above the bar, divided by the denominator. Okay, so set up the numerator. Set up the numerator in the division. They call this box, and the denominator outside. So this, if you had to do it out by hand, whatever is at the top always goes inside, and 8, where what's at the bottom, goes outside. Now, being in 8th grade, I wouldn't expect you to do this out. Okay? If you didn't have a calculator or you choose to, that's fine. But at this point, this is not a skill I'm assessing. So throughout this year, you will be allowed to use calculators when it's appropriate. And this would be a place where it's appropriate because this isn't the focus of the math we're learning. So I want you to grab a calculator and put 3 divided by 8 in your calculator to see what you get and to practice using it. And then come back and check what it was. So when you divide 3 by 8, you should have gotten 0.375. If you got something bigger than 1, so you had a whole number here, you probably divided it backwards and did 8 divided by 3, but it's always the top divided by the bottom, okay? So if you could flip to the back, or if you're just watching, I would also like you to try 5, 6, turning that into a decimal and see what you get. So go ahead and pause the video and then come back. So now that you've tried this, what you should have seen is it looked like this. So it was 0.8, and then that 3 was going on and on forever. If you're noticing a pattern like this where it's going on and on forever, or if you were actually to do 2/3 on your calculator, it would probably round this to 6666667. Assume it's a repeating decimal. Your calculator can only fit so many digits on its screen, so eventually it's either going to round it like it would with 2/3, or it's just going to stop because there's no more room. So when you see a pattern like we were noticing before in our examples, assume it's repeating and write it in bar notation. Okay. If you have questions, please reach out, and thanks for watching. I'll see you guys soon.